So this week in lab, we're going to be investigating several different RC circuits. I'm going to go ahead and wire this up first for reasons that are going to become obvious, and then I'm going to talk to you a little bit about the circuit. So if you, what you're going to do is for each one of these RC circuits, there are 7 of them on this board, you're going to attach a jumper wire. You'll need a single jumper wire for lab this week. And you're going to connect pin 3 of this op amp to the top, to the higher voltage sides of the capacitor on the RC circuit. And the reason why we're going to do that is this RC circuit is energized to 9 volts when I press the button. And this button will energize this capacitor, this button for this capacitor, and so forth. So each one of the buttons is going to energize one of the capacitors. The op amp, its only purpose is to prevent the LED from taking energy away from the capacitor. So the job of the LED is to monitor the state of the capacitor, but not to affect the state of the capacitor. So I've put this op amp in a simple unity gain kind of emitter follower configuration. So it will have infinite input impedance, but whatever the input is, it's gonna mirror that input to this LED. So what we're going to find is that the LED right now is simply monitoring the voltage that's on this capacitor, and after a certain amount of time, that capacitance, or the charge in that capacitor, is going to decay to 0. It's never actually going to reach 0. What happens is that this LED will turn off when it gets down to 1.6 volts. So we have the power supply is set to plus and minus 9 volts. So when it's going to start at 9 volts and it's going to decay down to 1.6 volts. That takes, oh, here we go. It's just about to decay. So it's about a minute and a half, minute and 35 seconds, and I'd say there it is. So we've reached the point where this capacitor has decayed down to 1.6 volts. We can then do the same thing for the other capacitors, one at a time. This one has about half as much capacitance as this one, so this should only take about 45 seconds. And so what we're going to find is that you can do the arithmetic, you can do the math to calculate how long this LED should stay on for each one of these RC circuits. Of course, as the capacitors get smaller and smaller, you can visually see that here. As the capacitors are getting smaller, the time is going to be less and less. So this is a 1,000 microfarad capacitor, 470. This is a 100 microfarad capacitor. This is a 47, and so forth, down to a I believe this one's a 10 microfarad capacitor. So we can see that after about 45 seconds, this LED is going to start to fade, and here it goes, and we're calling it. So that's how long it took that one. The next one should be even faster. And you're going to, in lab, you're going to be performing the same experiment and recording how long it takes for each one of these for the LED to turn off when it's attached to each one of these capacitors, and comparing, there it went, that one was much faster, and comparing it to how long you calculated that it should take. Because you're going to be able to do the math to figure out how long it should take. Now, of course, you can see that it's decaying much, much more quickly. And you'll be, oh, there, that one's really fast. Now, it's going to actually be quite hard to measure this one. So it doesn't hardly stay lit for very long at all. It's about a half a second. I believe the math works out to be about 0.45 seconds that it stays lit. So you're going to do those for 1, 2, 3, 4, 5, 6 RC circuits. Shouldn't take very long. You might want to do them a couple of times just to make sure that you get the time correct. But then you have a design problem. I've given you another capacitor here, and if I sort of zoom in, I don't know if you can see it, but it's a 470 microfarad capacitor. So what I want you to do is, given a 470 microfarad capacitor, I want you to choose the resistance. And the criterion is that the LED should stay on for between 9 and 11 seconds. Optimally, we'd like it to stay on for 10 seconds, but we'll be happy to accept anything between 9 and 11. So I've chosen a resistor. I'm not going to tell you what it is. And if I press this button, we can go 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, and I was probably counting too slowly. I'm using my phone to record this, so I can't use my phone to also time it. But I think that what you'll find is that if you, of course, if you choose a resistor that's the wrong value, it won't be between 9 and 11 seconds, but the goal is to hit right at 10 seconds that the light should stay on.